Morning, everyone. Thank you all for taking the time out of your busy schedules to attend this event. I would specifically like to thank Denise Ruffner, the founder and the president of Women in Quantum, and André König, the chairman of One Quantum, for making this event possible. I am extremely honored to have the opportunity to speak amongst such incredible women and leaders and role models in this field. I could not be more appreciative to be here today to talk about my personal experiences with coming into quantum and sharing a little bit about IonQ's technology as well. Additionally, I would like to mention that I would not be in the place that I am now without the support of fantastic colleagues, professors, teachers, friends, and family who have and who continue to support me as I pursue my interests. Similarly, support others as they pursue their goals. I think that this organization and community is a wonderful avenue to celebrate the achievements of women in quantum and women in STEM in general. So with that being said, I am very eager to share my journey that led me to my current role and to talk about IonQ's technology. Today's chat will cover my path to a career in STEM, specifically how I ended up at a quantum computing startup. When I decided to pursue an engineering degree and was studying mechanical engineering, I did not expect to be working in the field of quantum, but I'm obviously very excited to be here now. And then I'll transition to how some of my projects at IonQ and talking about our technology in general. For the past 3 years, I have been a mechanical engineer at IonQ, and at a high level, my work focuses on designing, simulating, characterizing, and assembling highly precise and stable elements that make up IonQ's quantum computer. As you may imagine, the system is quite complex with many different subsystems and many teams collaborating together so that we can achieve groundbreaking results. Design requirements often involve minimizing disturbances to sensitive aspects of the computer. We at IonQ, and I'll get into this a little bit more later, use a trapped ion approach to produce our quantum computing units, qubits, and the system needs to be extremely precise when you're pointing individual lasers at individual ions. So of course, I'll get into more of those details when I talk about some of my projects and talk about IonQ's technology in general. I studied mechanical engineering and business at the University of Virginia, and am currently located in DC as IonQ is based in College Park. Though you may imagine it was just a direct route from Charlottesville to DC, that was not actually the case. I took a job right after graduation in California before actually coming back to the East Coast to work with IonQ.
So one of the things I often find really hard is listening when people introduce me. They're not saying anything that isn't factually correct, and I still wonder who that person is. So it's this whole, are you uncomfortable when people say that you are all that in a cookie?
I was the kind of person that liked math when I was a kid. And when I was entering into high school, I was trying to figure out how can I actually apply math and make a job out of it. So I remember in high school physics class, we spoke about the double slit experiment, and that was very eye-opening, I think, for the kind of personality I had, because it made absolutely no sense and it was extremely counterintuitive. And that's kind of what directed me on the path of doing physics in undergrad.
At the core of it is this self-doubt, right? What if I fail? What if I am not everything that people think that I am?
I still remember the video was called Quantum Computing Explained. And after I watched it, there was so much more that I wanted to know. So I fell down the quantum rabbit hole that night, and every night after that for quite a while. Quantum really piqued my interest. It sounded like something out of a Marvel movie and had the potential to change the world.
Last year, actually, Chris Monroe, he asked me to join the company that he had co-founded, IonQ. And of course, I said yes, because I was very excited by their technology. And so here I am.
Working in such a dynamic environment with my colleagues allows us to wear a variety of different hats and get exposed to so many different projects and collaborate across the board on all of the different elements that build our quantum computer. Besides the fact that the company is building this fantastic technology, I really can't say enough about how wonderful the culture is that we have here. IonQ is a brilliant and a supportive community that supports one another to achieve our shared goals. From the ping pong table in the warehouse where I've gotten many lessons on how to play better table tennis, to the pre-COVID lunches where we would all take a shared lunch break to sit shoulder to shoulder and laugh. This is a really special place, and one that on both a technical and a cultural level is just a great fit. So now I'm going to transition a little bit to talk about some of the projects that I have had the opportunity to work on at IonQ. Within the first 2 weeks of starting, I jumped onto a project that eventually got submitted for a patent application. The project involved designing an assembly to actively stabilize a laser cavity, and cavity length stabilization is particularly important for locking the output frequency of the laser. So you have two mirrors this is a very, very simple explanation, but there are mirrors that are inside the laser cavity where a beam bounces back and forth. And if that length changes at all, and I'm talking on the order of nanometers or micrometers, you don't want to see that happen. And you'll see an output of your frequency of your laser change based on how that cavity length changes. And so the project involved a lot of mechanical design, dynamic analysis, control theory, design iteration, testing, and validation to ensure that what we were putting into the laser was actually stabilizing it actively. And it was extremely rewarding to see one of the first projects that I got to work on at IonQ ultimately get submitted for a patent, which I think I can speak for many engineers when I say that this is a huge milestone and a big achievement for anyone in their career. As of August this past year, we announced the commercial availability of our 11-qubit system with our cloud partners. And so if you're interested in running a quantum algorithm, you can do so on the cloud platform. And we also announced our next generation 32-qubit system, as well as our upcoming technology roadmap for the next 5 years.
And in an interview, she said, what I do is hard. And in any given performance, if I hit 80% of the notes, that's a win. And recognizing that someone with her talent and her capabilities can say perfection is not an attainable standard was really comforting to me. I thought that was very helpful. Do you keep track of your long-term accomplishments? Do you have, and I'm going to challenge you to do this, somewhere in your possession, either in your email or even in a paper folder if you're someone who still has those, or an electronic file folder on your desktop. You want to take a file that you call good things. And every time someone says thank you, every time someone appreciates something you do, every time you get a note back that says, good job, that was a really good insight, it needs to go into that folder.
What's next for you? And the answer is quite simple. I want to impact billions, change the world. And it might sound like a 15-year-old's naive dream, but that's okay. I want to solve world problems using cutting-edge technology and enable others to do the same.
So I'd first like to thank Denise, André, and Melanie for all of the hard work to get this conference up and running. I think it's a really great opportunity for, one, all of us to finally meet each other.